Hello everyone. So we'll start the signal system. So here the objective is to uh, cover the gate syllabus. So based on the gate syllabus, I prepared the list of the topic that I'm going to cover. So this is the syllabus that I got through the gate website. So this is the syllabus for the signal system. So uh, this is from the ECE syllabus I have taken. So the E and the instrumentation is kind of subset of this syllabus. So they don't have to worry about the any extra, like if there is any topic missing. So I have checked the electrical syllabus. So that is a subset of this syllabus. Okay. So in this topic, we will start with the fundamental of what is the signal and system, and then we'll go to the LTI system. So first we'll start with the what is the signal and what is system. Okay, that is not written here because on official website you will not see this. After that we'll go to the LTI system. This is the linear time invariant system, and from after this LTI system we will start all the Fourier series and then Fourier transform, all this transform that you see here, Laplace transform, jet transform, discrete time Fourier transform, and so on. And then at last, this sampling theorem we will cover at the last, and then the furthermore, like the last topic will be this group delay, phase delay, and digital filter design technique. So this will be the flow of the course. So first we will cover the basic of signal system, what exactly is the signal and what is the system, and then we'll go to the LTI system, and then we'll cover all the transformation of Fourier series, Fourier transform, Laplace, jet, and so on, and then we'll come to this sampling theorem, and then we'll go to this group delay, phase delay, and digital filter design technique. Let me continue. So first, let me cover what is the signal and system briefly. So since we are talking about signal here, so signal can be any physical quantity. It can be okay. Is anyone else not able to hear me?
I think we can hear, sir.
Okay, okay.
Everyone, please.
Someone message that is not able to. So this signal can be a mechanical signal or it can be an electrical signal. But since we are in electrical domain, so we will be talking about only the electrical signal. So since it is electrical signal, it will be either in the form of voltage or it will be in the form of current. So these are the two things that comes in under the electrical system, either the voltage signal or the current signal. Okay. So we have a system which you can think of this box as a system. There is an input signal, there is an output signal. So what the system does is take this input signal, do some processing here and give us some output signal. Okay. So based on how we want this system to perform some uh, activity on this input signal, you will get, based on that you will get the output signal. So this system can be designed based on our requirement to do some processing on the this signal. This you will see in other subject like analog communication, analog and communication system. Okay, that we won't cover. And the basic example I've shown here is you can think of this. There is a resistor here. There is a resistor here. There is an input voltage here. There is an output voltage here. So this resistor and this resistor, you can think of this complete thing as a system. Okay, and then this is the input and this is the output. So this is signal, this is signal, and this is also a signal. So this is the input signal, it is passing through the system and giving us some output signal. Okay, this is very basic example of a signal and system. How does these two quantity interact with each other, signal and system? So signal is a physical quantity. Okay, since we are talking about electrical, so it will be voltage and current. System is a electrical system which do some processing on the signal and give us some output signal. Now based on the characteristic of the signal, it can be classified into the multiple way. So one is the continuous time and discrete time signal, analog and digital signal, complex real, even odd, periodic aperiodic, energy power, and deterministic and random signal. So this category we will go through one by one and see. We will see some example. How do we classify the signal based on their property? So first we will see the continuous time and discrete time signal. So as the name suggests, uh, the continuous time signal will have continuity in the time domain, and discrete time signal will be discretized in the time domain. So if you see the graph of a continuous time signal, you will see this kind of curve. You will have the time domain as an x-axis, and y-axis is some electrical quantity. And when you plot this signal with respect to time, you will see a continuous function here. Okay? And that's why we call it as a continuous time signal. In the case of discrete time signal, the signal is defined only at discrete instances. For example, as you see in this graph, the signal is defined only at this particular time, or this particular time, or this particular time, and so on. Signal is not defined somewhere in between these 2 points, -5 and -4. Signal, we don't know what exactly the signal between -5 and -4. And similarly, -4 and -3 and so on. So the signal here is defined only at the discrete time instances, and that's why we call it as a discrete time signal. Now the continuous time signal, generally it is generally denoted by something like xc or ht or gt and so on. So t is the continuous time. In the case of discrete time, it's generally denoted by like xn or h of n or f of n and so on. Okay, so here n is the discrete time. Okay, n generally it takes only integer value. Okay, so n is only a integer value. Okay, so here the discrete time signal will take only value at the discrete time instances, and here the time value will be only discretized, or you can say a integer value. In the case of continuous time function, you'll see the continuity in the time domain. It means that for all the time, the signal is defined. Anyone has any doubt? We continue then.
Yeah, sir,
So,
can you please take thick pen?
okay, okay. Color also. Where is the pen
Yeah, on
option?
top line, colors and line you can see, no? The line erasures color on top it is coming, no, sir? Right and top.
Line, straight, no,
Stylus.
pencil.
Yeah, you can continue otherwise, sir.
I think there is no option.
Yeah, yeah, later on we can see.
Let me go to the next slide then. Now, next is the analog and the digital signal. So generally people get confused between the continuous time and discrete time with analog and digital signal. So in the case of analog signal, the y-axis will be continuous, not the x-axis. So in the case of continuous time signal, the x-axis was a kind of continuity. It was continuous time signal. In the case of analog signal, it is a y-axis which is going to be continuous. Okay? So in the color. So the y-axis will be okay. This much thickness is okay. This is the annotation of this one. Okay, wait. So in the y-axis, you will see the continuity. When I say continuity, it means that on the y-axis, it can take any value. Okay? It can take any value from minus infinity to infinity. There is no discretization in the y direction. Any value from minus infinity to infinity. That's what we call it as an analog signal. In the case of digital signal, the y-axis can take only discrete set of value. So yeah, as I saw on here in the example, this gn is taking only two set of value, either this +1 or this -1. Okay? So this kind of signal where y-axis is kind of discretized. So in this case, the y-axis will be discrete. Since y-axis is discrete in nature, it can take only finite set of value. For example, here we have only two value, +1 and -1. So in the case of analog signal, continuous value. In the case of this digital signal, it will be discrete set of value in the y direction. So x direction doesn't matter. X direction can be discrete or can be continuous for the analog signal. Similarly, for digital signal, x-axis can be discrete or can be continuous. So for here in this example, I have shown the discrete time digital signal, and here it is continuous time analog signal, but we can have the discrete time analog signal and continuous time digital signal. Okay. So this is the difference between what we saw in the last slide and this slide. Last slide was about the x-axis and this slide is about the y-axis. Let me go to the next slide. Now this is another set of example for analog and digital. So in this case, it is analog but discrete time. In last slide, it was analog but continuous time. Here it is discrete. Here it is discrete time. Sorry, continuous time and digital signal. In the last slide, it was digital signal but discrete time. Anyone has any doubt? Okay, let me go to the next slide then. Next is the complex signal and the real signal. So here, as the name suggests, the complex signal will have the complex component, which means that it will have a real part as well as the imaginary part. One example is complex exponential. In the case of real signal, signal will be real. It will not have any imaginary part. That is the only difference between complex and real signal. Okay? So complex signal will be kind of complex number. A real signal will be kind of a real number. Okay, it will not have any imaginary part. Let's go to the next slide. Now next is the even and odd signal. Even and odd signal are very similar to what we saw in the function, that is the even function and the odd function. So in the case of even signal satisfy this criteria. So in the case of even function, it satisfies this criteria. F of minus x is equal to f of x. In the case of signal, it will be x of minus t is equal to x of t. So if you plot this signal, you'll see that the signal is symmetric with respect to y-axis. So whatever the value that you see on the negative part of the time, the similar value, same value you'll see on the positive part of the time as well. Okay? So when you take this vertical axis and see the signal, it will look symmetric with respect to this vertical axis. That is the property of the even signal. In the case of odd signal, x of minus t will be equal to minus of xt, and similarly for the discrete time, x of minus n will be minus of xn. Again, it is same as function, f of minus x is equal to minus f of x. In this case, signal will look like this. Whatever you see the signal at the positive time, on the negative time, it will be negative of the this value. Okay. So here you see you have some, let's say some value a. At this time instance, you will get values, let's say minus a. So that is the property of the odd signal. So again, this even signal and odd signal are very similar to even function and the odd function. Anyone has any doubt? Now, how do we calculate the even part or the odd part of a given signal? Okay. So in the last slide, what we saw was the completely either even signal or the odd signal. But in general, signal can have both even part as well as the odd part. Okay. It may not be perfectly even or the odd signal. So for example, let's say I have a signal which looks like this. Okay. If you see this signal, it is neither even signal nor odd signal. Okay. It means that it will have a part which is a even and it will have a part which is odd. Okay. So in general, a signal can be composed of two parts. One is even part and another one is odd part. Okay. So in general, signal can be written as even part plus odd part. Okay. Now to calculate the even and odd part, you can use this formula. So odd part is given as x of t minus x of minus t by 2, and even part will be given as x of t plus x of minus t by 2. This you can derive it to this two property. Okay, this two equation you can use to derive to come to this value. So this is how we calculate the even part or the odd part of a particular signal. Take this formula and put this xt and x of minus t here and calculate the even part and odd part. In the next class, we will see for a particular signal how do we calculate the even part or the odd part. So this question I've taken one of the previous year gate problem. So we have been given a signal x of t, which is which looks like this. It is from minus infinity to 0, its value is 0, and from 0 to infinity, its value is 1. And for this signal, we need to find out what is the odd part and what is the even part. Okay. Now we know to calculate the odd part, we need to use this formula, that x of t minus x of minus t by 2. Okay. And to calculate the even part, we need to use this formula, x of t plus x of minus t by. Okay. Now x of t is already given. We need to find out what is x of minus t. So x of minus t is what? You take this xt and do the time reversal. So when you do the time reversal, you'll get this. To get the time reversal of any signal, you take the signal and flip it with respect to y-axis. Okay, this is y-axis. Just flip it around this y-axis. You'll get a time reversal. So this will be x of minus t. So this is x of t. This is x of minus t. Add this 2. Sorry, subtract this 2 here. Okay, and after the subtraction, divide it by 2. Okay. Now to find out the even signal, take this two, x of t and x of minus t. So x of t is this one, x of minus t is this one. Add this 2 and divide it by 2 to get the even part. Okay. So let's calculate the even part. So to calculate the even part, you take this 2 and add this. So when you take the x of t and x of minus t and add this 2, you will get this. So this is our x of t plus x of minus t. Okay. Because from 0 to infinity, x of t was 1, and from minus infinity to 0, x of minus t is 1. When you add this 2, you will get this kind of flat signal. So this is the time axis, minus infinity to infinity, and it's x of t plus x of minus t is always 1. Okay. Now we have by 2 here also. So when you do it by 2 here, divided by 2, its amplitude will also go down and it will become 1 by 2. Okay. So x of t plus x of minus t by 2 is always 1 by 2 from minus infinity to infinity. So you can say that the even part is 1 by 2. Okay. So now we have got the even part. So even part is 1 by 2. So this option and this option will go away. Now we are left with this two option. Okay. Now to calculate the odd part, we need to take this x of t and x of minus t and subtract this two. Okay. So this is x of t. This is x of minus t. When we subtract this 2, you'll get this kind of signal. So x of t will remain as it is, but x of minus t will be something like this. Okay. This is plus 1 and this will be minus 1. Okay. Now after that we have divided by 2. So when you divide it by 2, it will become half and this will become half. Okay. So this is the signal that you have for the odd part. Okay. This is the XOT. Okay. So this is the odd part of the signal. Now you can write it in the form of xt. Uh, so if you see this signal, when you add this 1 by 2 in this signal, what will happen that this minus 1 by 2 will get cancelled. So what I'm doing here is that I'm taking this odd part here and I'm adding it with 1 plus 1 by 2. Okay. So first clear this. So this is x naught t. Let's calculate the x naught t plus 1 by 2. So when you do x naught t plus 1 by 2, you are adding 1 by 2 in x naught t. So when you add 1 by 2 in x naught t, what will happen that this minus 1 by 2 will get added with 1 by 2 and it will become 0. And this 1 by 2 will get added with this 1 by 2 and it will become 1. So from minus infinity to 0, you'll get 0. So minus infinity to 0, you'll get 0. And from 0 to infinity, you'll get 1. Okay. So you see this x naught t plus 1 by 2 is actually the xt. So you can say that x naught t is equal to xt minus 1 by 2. Okay. So this will be the odd part and 1 by 2 is the even part. So this 1 by 2 is even. I think here there is a one thing missing. There should be like plus sign here. Anyone has any doubt here? Let me go to the next slide. Next is the periodic and aperiodic signal. So here the periodic signal is the signal which repeats itself after some time interval. Okay, so for example, this x of t that you see here, it is repeating itself after some time interval. So this kind of signal is known as a periodic signal, and the signal which doesn't repeat itself after some time interval, we call them as a aperiodic. Okay? Now, in this case, when you see this periodic signal, this is repeating itself after every capital T. Okay. Now you can also say that this is repeating itself after every capital 2T also, right? You see this pattern, and then this pattern is again repeating here. So this is repeating after every T, 2T, and so on. 3T, 4T. So you can say that all this number that you see here, capital T, 2T, 3T, 4T, all these are time period. Okay. So the time period is a number after which the signal repeats itself. In this example, it can be T, it can be 2T, it can be 3T, and so on. But there is a one more term called fundamental time period. Fundamental time period. So the fundamental time period is the value of the time period which is minimum. Okay. In this case, the minimum value is capital T. Rest of them, that 2t, 3t, 4t, and so on, are more than capital T. This capital T, what we call it as a fundamental time period. So time period can be any number like 2t, 3t, 4t, or capital T itself. But the fundamental time period is only one number, that is capital T. So that is the difference between if you simply say what the time period and if you say fundamental time period. Anyone has any doubt? Let me go to the next slide then. Next is the fundamental frequency. So fundamental frequency is just opposite of the fundamental time period. So the time period unit will be in second, but frequency will be given as either opposite of the second, which is 1 by second, or generally it is written as hertz. Okay. This fundamental frequency is also called as a linear frequency. There is a one more frequency called angular frequency. So angular frequency is given as a omega equal to 2 pi f, where f is the linear frequency and omega is the angular frequency. So omega is equal to 2 pi by t. So you need to remember the difference between what is the linear frequency and what is the angular frequency, and what is the unit of f and what is the unit of omega. So unit of f is always hertz and unit of omega is radian per second. So omega unit is radian per second and the unit of f is hertz. So this is for the continuous time signal. For the discrete time signal, the angular frequency is given as omega. So this is generally denotion for the discrete time. So it will be given as 2 pi by n, where capital N is the time period of the discrete time signal. Now one example of the periodic signal is sine omega naught t or sine 2 pi f t. Okay. We know that this sinusoidal signal are periodic signal, and the omega here is angular frequency and f here is linear frequency. Okay. So this a sine omega t is always a periodic signal, and same about this a sine 2 pi f t. This is also a periodic signal. Anyone has any doubt? We go to the next slide then. Now let's say you have a signal x of t which is composed of two signals. Let's say x1t plus x2t, and we know that this x1t is a periodic signal and the x2t is also a periodic signal. Now we need to find out whether this x of t is periodic signal or not. So there is one easy formula to find out whether this xt will be periodic or not. So since this x1t is periodic, let's say its time period is t1, and x2t is also periodic, let's say its time period is t2. So to find out whether this xt is a periodic or not, just take the ratio of t1 and t2 and see whether this t1 by t2 is rational number or not. Okay. So if t1 by t2 is a rational number, okay, it means that this x of t is a periodic signal. Okay. If this is a rational number, then it means that x of t is periodic. Okay. But if it is an irrational number, in that case, this signal x of t will be aperiodic. Okay. So let me give you guys one example. So let's say we have a x of t. So I am taking this example from one of the previous year gate problem again. Let's say this is 2 pi t plus sine t pi t. Okay. This is the signal xt. We know that this signal is a periodic signal. We know that this signal is also a periodic signal. Okay. Here omega is 2 pi. Here omega is 3 pi. Now to calculate the time period, we need to calculate t1 equal to 2 pi by omega 1 and T2 equal to 3 pi by 2 pi by omega 2. So omega 1 is 2 pi and omega 2 is 3 pi. Okay, so this T1 will come out to be 1 and T2 is 2 by 3. Okay, so we know what is the individual time period. Okay, now to find out what is it, whether this signal is periodic or not, you need to just take the ratio of T1 and T2, and in this case you will get 3 by 2. This is a rational number, and since this is a rational number, the signal xt is a periodic. Okay, so this xt will be periodic signal because this T1 by T2 is a rational number. Now let's take another example. Let's say we have a signal y of t which is equal to sine 2 pi t plus sine under root 2 pi t. Okay, in this case we have a different signal here. Now let's see whether this yt signal is a periodic or not. So again t1 will simply be 1 because we have already calculated here. Now t2 will be given as 2 pi by omega, which is under root 2 pi. If you solve this, you will get root 2 here. Okay. Now let's calculate T1 by T2. So T1 by T2 is 1 by root 2. Now this is 1 by root 2, and we know that root 2 is an irrational number. Okay. So it means that this 1 by root 2 is irrational number. And since this is irrational number, this yt will be aperiodic. So even though this signal is a periodic signal, this signal is a periodic signal. Okay, so this sine 2 pi t is a periodic signal, sine under root 2 pi t is a periodic signal, but yt is not a periodic signal. Okay, so generally people get confused here and just stick that this is a periodic signal, but you need to check that T1 by T2 and see whether it is a rational number or not. So if it is a rational number, it will be periodic. If it is an irrational number, it will be aperiodic. Okay. Now, if you have a, let's say, more than two signal, so it is just I have shown summation of only two signal. If you have, let's say, sine 4 pi t, sine 3 pi t plus sine pi t. Okay, in that case, you have a three signal. Calculate T1, T2, and T3. Then calculate T1 by T2, and then calculate T1 by T3. Okay, T1 by T2 and T1 by T3. You don't need to calculate T2 by T3, just this much is sufficient. T1 by T2 and T1 by T3, and see whether these two are rational or not. Similarly, if you have, let's say, summation of 4 signal, in that case you will get T4. In that case you need to calculate T1 by T2, T1 by T3, T1 by T4, and see all 4 of them are rational or not. If it is not a rational, it is irrational, then it will be aperiodic. So this is how we find out whether signal is periodic or not. Anyone has any doubt? Now, once we know that the signal is a periodic signal, let's say in this case this xt is a periodic signal which is composed of two different signal x1t and x2t, and their time period is t1 by t2, and we calculated t1 by t2, it is a rational number, and we concluded that it is a periodic signal. Now once we know that it is a periodic signal, let's say we want to find out what is the time period of this x of t. So to find out the time period of x of t, we use this formula. Okay. So let's say this t1 is some number which is some rational number, and this t2 is also some number. Calculate the LCM of the numerator of the t1 and t2 and divided by HCF of the denominator of the t1 and t2. Okay. So this is how we find out what is the time period of the signal, which is composed of two different signals. Okay, if one is cos, then what we do here? Okay, so this is again very simple. When something is cos, so let's say one is sine 2 pi t, one is cos, let's say 4 pi t. We know that this signal is periodic signal. We know that this signal is periodic signal. Calculate the time period t1, calculate the time period t2. Just divide this by this two and see whether this is rational or not. You don't need to worry about whether it is a cos or sine or some other kind of rectangular periodic signal or triangular periodic signal. You don't need to worry about those. You just need to find out the time period and divide those two. Is it clear? So let's see if we have this signal. So till now we have seen that this signal is the signal which is a periodic signal, right? Right one is aperiodic. Since it is aperiodic, we don't need to find out the time period of this. Now, since this signal is a periodic signal, we can find out what is the time period of it. So what was the formula? T is equal to this one, LCM of the numerator and HCF of the denominator. Okay. So we need to find out LCM of the numerator and HCF of the denominator. Okay. So T1 is 1. So you can say this is 1 by 1 and T2 is 2 by 3. So numerator is 1 and 2. So you can say LCM of 1 and 2. And then denominator we have 1 and 3. So HCF of 1 and okay. We just need to calculate this and this will give us the answer. So when you calculate this, so LCM of 1 and 2 will be 2 and HCF of 1 and 3 will be 1. So this will come out to be. So this is how we find out the time period of the periodic signal. Anyone has any doubt? Okay, let me go to the next slide then. So till now, whatever we have discussed is all about the continuous time sinusoidal signal. Now let's talk about the discrete time sinusoidal signal. Okay? So discrete time sinusoidal signal is given by this formula. Okay, xn is equal to a cos omega n phi, where omega is the angular frequency and phi is the phase. Okay. In the case of continuous time sinusoidal signal, if you have just one sinusoidal, there is no other term here. Is there any doubt here? So in the case of continuous time sinusoidal signal, if we have just one cos term or sine term, no matter what is the value of omega naught, this signal will always be periodic, given that there is no other term here, just one cos or one sine term. Okay, just one sinusoidal term. But in the case of discrete time signal, if you have a cos term or a sine term and you have some value omega here, it may or may not be periodic. Okay, it depends on what is the value of this omega. Okay. Now, in the case of discrete time signal, this omega has to satisfy this criteria, that omega divided by 2 pi should be equal to m by n, where m and n are integer. Okay. It means that omega upon 2 pi has to be a rational number because it is ratio of two integer. Okay. So in the case of continuous time, there was no criteria on the omega naught for it to be a periodic signal. But in case of discrete time signal, there is a criteria on this omega for this discrete time signal to be a periodic signal. Okay, and that is this criteria: omega by 2 pi is equal to m by capital N. And if it is satisfying this criteria, this x of n will be periodic signal. And if it is not satisfying this criteria, it will be aperiodic. Okay. Now let's say this x of n is satisfying this criteria. In that case, this x of n will be periodic signal. And let's say we want to find out what will be the time period of it. Okay. So once you divide this omega with 2 pi, you will get some ratio, let's say m by n. Okay. This m by n you represent in such a way that it cannot be further reduced. Okay. And once you arrive at the point that this m by n cannot be further reduced, whatever the value in the denominator that you are getting will be the time period of the x of n. Okay. In the continuous time signal, it is pretty straightforward, t naught equal to 2 pi by omega naught. But in discrete time, you do this omega by 2 pi, get this ratio, reduce it such a way that it doesn't get further reduced. There is no way it can be further reduced. And whatever the value that you get at the denominator, that will be the time period. Okay. So this capital N is a time period of this discrete time signal. Anyone has any doubt? Okay, I have taken one of the previous year gate problem, and here we need to find out the time period of the signal Vt. This is pretty easy. This is composed of three sinusoidal signal, 30 sine 100t, tan cos 300t, and 6 sine 500t plus pi by 4. Okay. Now for this signal, we need to find out what is the effective time period, okay, of this Vt. So for that, you need to find out what is the T1, what is the T2, and what is the T3, and then use this T equal to LCM by SCF. Okay. So T1 will be equal to 2 pi by omega, which is 100. T2 will be equal to 2 pi by 300, and T3 will be equal to 2 pi by 500. Okay. Now here T will be equal to LCM of 2 pi, 2 pi, 2 pi. All this 3 has 2 pi in the numerator divided by HCF of 100, 300, and 500. Just this much you need to calculate, and this one will give you the answer. Okay. So when you calculate the LCM of 2 pi, 2 pi, 2 pi, you will get 2 pi itself. Okay. When you calculate the highest common factor of this one, you will get 100. Okay. So this is the time period. Okay. Time period is equal to 2 pi by 100. We need to find out what is the fundamental frequency in radian per second. Okay. So be careful about this unit here. It's not hertz, it's radian per second. It means that we are talking about the angular frequency, which is omega. Okay. So omega is equal to 2 pi by capital T. Capital T we have already calculated here. So it will be equal to 2 pi by divided by 2 pi by 100. And this will give us 100 here. Okay. So in this problem, the answer will be 100 radian per second. Let me go to the next slide. Okay. Now this problem was asked in GATE 2011, and this is just a derivation that we did in a few slides back. So we have a continuous time signal. We know that this signal is always a periodic. Okay. But in the question it is mentioned that, however, for a discrete counter time part, which is xn sine omega naught n, is to be periodic, the necessary condition is. Okay. We need to find out what is this necessary condition. So just few slides back we derived that it should be omega naught upon 2 pi should be rational number, or it should be a ratio of two integer. Okay, ratio of integer. Okay, that's what it has to be. Here, if you see the option A, it is not satisfying. Option B is also not satisfying. D is none. If you see the option C, 2 pi by omega naught to be ratio of integers. We have talked about omega naught by 2 pi, but it doesn't matter. Whether you take 2 pi by omega naught or omega naught by 2 pi, it will still be the ratio of the two integers. If omega naught by 2 pi is 2 by 3, 2 pi by omega naught will become 3 by 2, which is still a ratio of two integers. Okay? So this C will be the correct answer, that 2 pi by omega naught to be the ratio of integer. Anyone has any doubt? Okay, let me go to the next slide then. Okay. Now in this problem, we have been given a periodic signal xt, which is equal to 1 plus 0.5 cos 40 pi t multiplied by cos 200 pi t. Here, be careful, here it is a constant plus a periodic signal multiplied by a periodic signal. Okay, this is periodic signal, this is periodic signal, this is a constant. Okay, so whenever you have a constant getting added with periodic signal, the signal will always be periodic. Okay, this has to be constant though. So if you have a periodic signal added with constant, resultant will be periodic. Okay, so that means that whatever is there is in this bracket, this complete signal is a periodic signal multiplied by another periodic signal. Okay, so in this case we have a xt, which is x1t multiplied by x2t. Okay, now the derivation that we did for the summation of two signal, to find out the time period of the summation of two signal, was this one, right? We arrived at this result. Okay, the same thing, the same can be used for the multiplication also. So in this case, two periodic signal are getting multiplied, and we need to find out what will be the effective time period of this x of t. So x1t time period is, let's say, t1, x2t is time period is, let's say, t2. You just need to do the LCM of the numerator of the t1 and t2, and then SCF of the denominator of the t1 and t2. That will give you the time period of this one. And then from the time period, we can find out what is the fundamental frequency. Now in this problem, the frequency we need to find out is in hertz, not in radian per second. Here the unit is different. So it means that we need to find out f, not omega. Now, what is the time period of this x1t? So t1 will be equal to, this is the omega, which is 40 pi. So 2 pi by 40 pi. What is the t2? T2 is 200 pi t. This is omega naught. This omega 2 is 200 pi t. So it will be 2 pi divided by 200 pi. Okay. So T1 will give you the 1 by 20. T2 will give you 1 by 100. Okay. Now we know what is the value of T1 and T2. Let's find out what is the effective time period, which is LCM of the numerator, which is 1, 1 divided by HCF of the denominator, which is 20 and 100. Okay. So when you calculate this, you'll get 1 by 20. So this is the time period when you calculate the fundamental frequency, which is equal to f equal to 1 by t, where capital T is the time period. Okay, yeah, you can use a trigonometric formula here. You can use this cos A into cos B formula, but that will be pretty lengthy. You need to separate them, okay, and then use the summation formula that we derived. Okay, that also you can do, but it will take slightly more time than this one. So this is t is 1 by 20, 1 by t will be 20. So this 20 will be the answer. Is it clear? Did I clear the doubt? Anyone has any doubt? So the question here is, one guy has asked whether we can use the trigonometric formula of this cos A into cos B. You can use it. You can separate. You will get 3 terms in total. So this cos 200 pi t will get multiplied by this one. So you'll get cos 200 pi t plus this 0.5 cos 40 pi t multiplied by cos 200 pi t. Okay, so this term is clear. This term has cos A into cos B. So you can apply the formula of the cos A into cos B and separate them. Okay, and then you will have total 3 term and you can find out the effective time period, okay, from there also. Sri, did I clear your doubt? Okay, let me go to the next slide. So till now we have discussed a few of them. Now there are few remaining classification. So one is deterministic signal and random signal. This random signal we will not cover in signal and system. This will come back in communication system. This deterministic signal is this what we will be covering throughout the signal and system. Okay. So the deterministic signal is a signal which we know beforehand what kind of uh, uh, function it has or what kind of waveform it has. Okay. That because we know from the beforehand that what kind of waveform or what kind of function it has, we call it as a deterministic signal. Okay. The random signal is something which we don't know. Okay, what the value it is going to take in the future, or what are the value it is going to take based on the particular experiment. Okay, so for example, if you toss the coin, you don't know what the outcome will be, whether it will be head or tail. Okay, because it is random in nature. So those outcome will give us the random signal. Okay, this random signal will cover in the communication system, not in the signal system. This deterministic signal is the signal which we know from the beforehand what kind of function or what kind of waveform it has. For example, x is equal to e to the power minus t. Since we know this waveform, we can plot it like this. Okay, minus infinity to infinity, we can plot it. Similarly, this sin omega t also we can plot it because we already know this is deterministic signal. But random signal, unless the experiment is done, you cannot plot it. So you can plot only the past value where you have the experimental result. Okay, and also those experimental result will not be fixed. So for example, let's say today you are tossing a coin at this particular time instance, you are getting head, and because of that you are saying that it is one. Next day, if at the same time, if you toss the coin, you may not get head back. It may be tail or something else. Okay, because it is random in nature. So that's the difference between the deterministic signal and the random signal. Anyone has any doubt here? Okay, let me go to the next slide then. This is an important classification, which is energy and the power signal. So if you remember from the network theory, let's say you have a voltage that you are applying it through some resistor, some current will be flowing through this resistor, which will be given by I equal to V by R. Okay. Now the power consumed by this resistor will be given as I square into R or V square by R. Okay. This thing we know from the network theory. Now, in the case of signal and system, we assume that this R is kind of normalized to 1. Okay, this R is 1. It means that once R becomes 1, your power will be simply I square or V square. Correct? So signal will be either current square or the voltage square once R is equal to 1. Okay. Now in the signal system, the power that we calculate is kind of independent of, we don't care about this R because we have normalized this R. We assume that this R is 1. Since R is 1, power is simply equal to I square if it is current signal, and it is V square if it is a voltage signal. And since it is simply the square of the signal, in general, let's say if you have a x of t, power will be simply given as x square t. Whether xt is a voltage or current, it doesn't matter, because once R becomes 1, it is always equal to signal square, whether it is a current signal or the voltage signal. So in general, in the signal system, the power will always be given as P equal to x square t. Okay. This is what we call it as the instantaneous power. At a particular time t, the power is x square t. Okay. So in the signal system, you will never see a signal is defined as a current or a voltage. Signal is just defined as a signal. Okay. Because of this thing only, that we normalize this R equal to 1, and once R becomes 1, whether it's a current or voltage, it doesn't matter, power is always equal to x square t. So this power is instantaneous power. Now we know that power, from the power you can calculate the energy. Okay, so the energy is given as E equal to power into time. Okay, power into time, when you do, you will get the energy. And since this power is a function of time, if you want to calculate the energy, you need to integrate this time. Okay, integrate this pt to calculate the overall energy. So you take this power, which is x square t. Okay. Now here, if you see, I have put mod here. Here I have not put mod here. So we put the mod when you calculate the power or energy if the signal is a complex signal. Okay. So if this x is a complex, you need to put the mod and do this integration, or you need to put mod here also. But if the signal is a real signal, you don't need to put mod there. So this mod has its uh, this mod is important only when the signal is a complex signal. If it is a real signal, this mod doesn't matter. So this is the power term, x square t multiplied by time will give us the energy. Okay. Anyone has any doubt? So this is the formula to calculate the energy of any signal xt. Let me go to the next slide. Now let's see, how do we classify the signal as a power or energy signal. Okay. So in the last slide, we just saw the formula to calculate the energy. Okay. If you see this energy formula, limit t tending to infinity, once you put limit t tending to infinity, limit will be minus infinity to infinity. So that's what it is written here. E is equal to minus infinity to infinity mod of x square t dt. Okay. This is the formula for the continuous time signal. For the discrete time signal, the energy is calculated by this formula. Now when you calculate the power, energy will be equal to power into time. So the power will be equal to energy divided by time. Okay. So what we do here is that this term that you see here, that I'm just highlighting here, this is the energy term. This is E. Okay. Take this E, divide it by this time term, and this will give you the power. Okay. So if in the last slide I wrote the power as a power equal to x square t. This power is instantaneous power, not the average power. If you want to calculate the average power, you need to do the average over the time, and because of that we use this formula. Okay. Calculate the total energy divided by t and limit t tending to infinity. So this is how we calculate the power of the power signal. This is how we calculate the energy of the energy signal. For the discrete time signal, this is the formula to calculate the power. It is very similar to this one. This if you correlate this to, okay, the time over which I am doing the summation is minus n to n. So the number of the discrete time is 2n plus 1. Okay, it is from minus n to plus n. If you calculate the number of discrete point here that we have, okay, so it is 1, it is minus 1. So minus 1 to minus n, total n point. 1 to capital N, total again n point, and there we have 0 also. So 2n plus 1 in total. So that is the total number of discrete points we have. That's why we are dividing it. That is the time. So this is the energy, and this is divided by the time will give us the power. So energy divided by this time is power. Okay. Now, if you have an energy signal, energy of that signal will be a finite number. Okay. When I say finite number, it means that it has to be greater than 0 but less than infinity. Okay, and the signal is called the power signal if power is greater than 0 but less than infinity. Okay. If energy of the signal is 0 or infinity, it will not be the energy signal. If the power of any signal is equal to infinity or equal to 0, it won't be the power signal. Be careful that there is no equal to sign here. It is greater than, greater than. There is no equal sign here. Okay. So P has to be greater than 0, not greater than equal to 0. Now, one more thing to note here is that if the signal is an energy signal, it won't be the power signal. And if the signal is a power signal, it won't be the energy signal. Or in other words, a signal can't be both power and energy signal. Okay, it can be either energy or it can be power. It can't be both energy and power. Okay. Now, any signal which doesn't satisfy these two criteria, those signals are neither energy nor power signal. Okay. Any signal which doesn't satisfy this criteria. So for example, let's say for a particular signal, energy is also infinity and power is also infinity. That signal is neither energy nor power. Anyone has any doubt till this point? Okay. Now, if you see this, let's say you have calculated the energy of the signal, and let's say I am talking about the signal which is already an energy signal. It means that this integration will give me a finite number, let's say A, right? Then only I will say that the signal is an energy signal, correct? Now, if for the same signal I am going to calculate the power, what will happen that you see this integration. If you see this integration on the right side, this is essentially energy, right? Once you put the limit t tending to infinity, this will become minus infinity to infinity integration of mod x square t dt, which is same as E here. It means that this integration will give us A. Okay, this will give us A, and then divided by we have t and limit capital T tending to infinity. Once you put capital T tending to infinity, this A is a finite number because we know that we are getting because it is an energy signal. So if the signal is an energy signal, you'll get finite energy A, let's say. When you're going to calculate its power, it will be something like this, limit t tending to infinity A by capital T. Now, once this capital T will become infinity because here T is tending to infinity, this complete thing will become 0. So any signal which is an energy signal, because it has a finite energy, its power will be equal to 0. And since its power is equal to 0, it won't be a power signal because for it to be a power signal, power has to be greater than 0. Is this point clear now? Okay, now in the same way, let's say a signal is a power signal. Okay, now I'm talking about a different signal which is a power signal. Since this is a power signal, let me assume that the power of this signal is a B. Okay, now this complete thing is a B. Okay, in this case, now this E, you can also write it as a power multiplied by capital T, limit T tending to infinity. Okay, rub this thing. So let me assume that this power is this, we are talking about a signal which is a power signal and its power is B. Okay, so power is equal to B, which is also equal to limit T tending to infinity 1 by T into energy, right? Just now we saw. So this power is equal to B, and this power is equal to B, which is also equal to limit T tending to infinity 1 by capital T multiplied by E. Or you can say this E is equal to B into T, where limit T is tending to infinity. What I've done is I have taken this capital T on the left side multiplied by B, and limit is still T tending to infinity. Now this is a finite number, this B is a finite number, this T is infinite because T is tending to infinity. So this energy will become infinity. Okay, so any signal which is a power signal, its energy will be equal to infinity. And since energy is infinity, it will not be an energy signal because energy has to be less than infinity. Okay. So now this 2 point is clear why power signal will not be energy and energy signal will not be power signal. Okay. Anyone has any else doubt? Okay. So we can have a three category of signal. It can be energy, it can be power, so this is first category, this is second category, third category is neither energy nor power. Okay, so based on this definition of energy and power, signal can be of three type here: energy signal, power signal, neither energy nor power signal. Okay, in the case of neither energy nor power, the signal doesn't satisfy both of this criteria. Let me go to the next slide. So the last slide that we have seen is for the generalized signal. It can be used for any kind of signal. Now, if you have any periodic signal, okay, if you have any periodic signal, it will always be a power signal, or it will either be a power signal or neither energy nor power. It cannot be a energy signal. If you have any periodic signal, it cannot be a energy signal. Okay. The reason is very simple. If you have a periodic signal, let's say something like this, okay, let's say this is xt, this is a periodic signal and repeating itself. Okay, now to calculate the energy of this signal, what you will do, you will put the energy, this formula, take this formula and put this xt here. Okay, now this xt that you see here, you take this xt and square it and put it here. Okay, now if you see this xt is periodic signal. It means that this is going to repeat itself all the way from minus infinity till infinity. Okay, and because of that, when you integrate this complete thing, square it and integrate it, this complete thing, you will get infinity. Okay? You will never get a finite number for a periodic signal. Okay? So because of that, if you have any signal which is a periodic signal, it will never be an energy signal. It can either be a power signal or neither energy nor power. Okay. So let's say that a signal is a power signal and periodic signal. Then to calculate the power, you can remove the limit that we put that we are putting, that limit t tending to infinity, that you can simply remove it, and you can use simply this formula to calculate the power. This you should use only if signal is periodic. Okay, if signal is not a periodic signal, you should not use this formula. Similarly, for the discrete time signal, which is a periodic with capital N, okay. So in sorry, not capital N, yeah, where 2n plus 1 is a periodicity. So in that case, the power will be given as 1 by total time period and summation over total time period. Here integration is over the time period divided by one this time period. Here it is summation over the time period divided by this time period. Okay. This is how we calculate the power of the periodic signal. Now let's take example. We need to find out what is the power of the signal st, which is equal to 8 cos 20 pi minus pi by 2 plus 4 sine 15 pi by t. So with this problem, I will tell you guys one more like important thing, that is, if you have a summation of two sinusoidal signal, then how to calculate the power. Okay. So if you have, let's say, this signal as xt, you can say that this is x1t and this is x2t. Okay. When you calculate the power, you will be calculating like this: minus t by 2 to t by 2, 1 by capital T, mod of x square t. Since it is real, I am not taking mod x square t dt. Okay. Now this st is composed of x1t and x2t, so it will become 1 by t minus t by 2 to t by 2. St will be x1t plus x2t square dt. Okay. Now if you further simplify this, you will get 1 by t minus t by 2 to t by 2 x1 square t plus 1 by t minus t by 2 to t by 2 x2 square t plus 1 by t minus t by 2 to t by 2 2x1t and x2t, okay, dt. Now if you see the first two term here, this two, the first term is the power of the x1t, let me call it as a p1. The second term is the power of this second term p2. Now the third term that you see here, this is what we call as a correlation of this two signal, x1t and x2t. Okay, and for the sinusoidal signal, any kind of sinusoidal signal, this integration always yield to 0. Okay, and that is important when you have a summation of multiple sinusoidal signal. Okay, this sinusoidal, when you add this when you have this term for the sinusoidal signal, this term will always yield to 0, because when you put any sinusoidal signal and do the integration, you'll always get 0. Okay, so because of that, whenever you calculate the power of any sinusoidal signal or summation of sinusoidal signal, the power will simply be the power of this term plus power of this term. You don't need to care about this third term, which was the multiplication of this two and then integration. Okay, only when you should do this only when the signal is sinusoidal signal. Okay, if you have some other signal which is not a sinusoidal signal, in that case you need to check this value. Okay, that is important point to note. You should remove this term only when both signal are sinusoidal. If they are not sinusoidal, you should, okay, what is the reason for that? Okay, so let me say that I am integrating it. Okay, x1t into x2t, let me say that there is a sine A and there is a cos B. Okay, there is a sine term, there is a cos term. We are integrating it over the time period of this signal. Okay, you can say that this is sine A minus B. Wait. Guys, we will take 2-minute break and then we will continue. Yeah, so we were here. So in this case, yeah, there is sine A into cos B term here. Now you can write it as a 1 by 2 sine A plus B and plus sine A minus B. Okay, and then doing this, we do this integration from minus t by 2 to t by 2, 1 by capital T. Now we are doing, so this is a one sinusoidal, this is another sinusoidal. We are doing this integration over minus t by 2 to t by 2. Now this capital T we generally choose such a way that this complete term is a periodic signal. Okay, this thing is a periodic. Okay, it means that when you plot this sine A plus B over minus t by 2 to t by 2, it will complete its cycle. Okay, what I mean is that, let's say this is minus t by 2 to t by 2. If you plot this sign, it is going to look like this. Okay, you see this is completing its cycle, right? So since it is completing its cycle, now when you integrate over this minus t by 2 to t by 2, essentially what you are doing is calculating area under the curve, right? Sine A plus B, area under this. Okay, so when you calculate area under the curve, this area, this is a positive area, will get cancelled out by negative area. This positive area will get cancelled out by this negative area, and so on. All the positive area will get cancelled out by negative area, and essentially this integration will yield to 0. Okay. Similarly, sine A minus B will also be like that. When you plot it from minus t by 2 to t by 2, it will have the number of cycle will be integer multiple of the, so it will have integer multiple of the cycle, and because of that, when you integrate it, the positive area will get cancelled, the negative area, and you'll get a integration equal to 0. Or you can do the direct integration, just do this integration, put the cos and put this limit, then also you'll get 0. This is easier way to understand through this area under the curve. Is it clear? Okay, so because of that, we don't care about this multiplication term when we have the when we are calculating the power of the summation of two sinusoidal terms. Okay, now let's calculate the power. So first we should know what is the power of the single sinusoidal. So if you have any signal x of t, let's say it is a cos omega naught t plus theta, so its power is given as a square by 2. Okay, similarly if you have, let's say, a different signal yt, which is equal to, let's say, b sine omega naught t plus 5, its power will also be given as b square by 2. So you just need to take the amplitude of the sinusoidal, make the square of it and divide it by 2. That will give you the power of the sinusoidal signal. Okay. So in this case, we have first this term and then we have this term. We need to find out what is the power of this term and then power of this term. Add this 2, that will give us the answer. Okay. So the power of this term will be 8 square by 2. Power of this term will be 4 square by 2. Okay, just add this 2. So this is 64 by 2, that is 32. Well, this is 16 by 2, which is 8. And this will give us the 40. Okay. So this will be the correct answer. Now let me solve the second problem. Which of the following sequence is not a power signal? Okay. So we need to find out which sequence out of this doesn't have is not a power signal. First is a unit step sequence. So how does a unit step sequence looks like? So this is how the unit step looks like. This is a discrete time signal. This is how the unit step look like. Okay, this is un. Okay. Its value is 1 from n equal to 0 till infinity. Okay. We want to calculate the power of this signal. So the power is given as limit n tending to infinity 1 by 2n plus 1 summation x of n square n equal to minus n to capital N. Okay. Now when you solve this, you can write it also like this: n equal tending to infinity 1 by 2n plus 1. Now if you see this here, from n equal to minus n to minus 1, okay, let's say this is minus n, this is minus 1, this is 1 0, this is 1, and let's say this is capital N. There will be lot of other number also. I'm just not, this n is some general number. Let's say this is the n. Now from minus n to minus 1, value of xn is 0, but from n equal to 0 to capital N, value of n is equal to 1. Okay, so when you do the square of it and add it, this is the un. When you do the un square, it will still be 1, right? Because 1 square is also 1, so this will be 1 1 1 1 and so on till infinity, and we are at this point n. Now if you take this un square, add it from minus n to n, from minus n to minus 1 it will be 0, and from n equal to 0 to capital N it will be 1 1 1 1 1. So when you add all this 1, the number of 1 here is n plus 1, right? Because from 1 to n you'll get total n, and then there is a 0 here. So when you solve this, you'll get n plus 1 here. Limit n tending to infinity. Just apply the limit property and you'll get 1 by 2 here. Okay, so it means that this is a power signal. Okay, similarly, if you calculate, this will also be a power signal and this will also be a power signal. Okay, when you see this unit ramp, this won't be a power signal. If you calculate the power for this unit ramp sequence, so the ramp, this is how the ramp looks like. It continuously grows up. Okay? N equal to 1, its value will be 1. N equal to 2, its value will be 2. N equal to 3, its value will be 3, and so on. So you can say that this unit ramp is simply equal to n for n greater than equal to 0 and 0 for n less than 0. Because for n less than 0, its value is not there. For n greater than 0, you see all these values. Okay? So when you take this n and put it in this power formula, you'll get infinity. Okay, since the power is infinite, this unit ramp will be not a power signal. Okay, so this will be the correct option. So let me solve the power of this unit ramp, then it will be clear. Let me remove this. So you can write it as a p equal to 1 by 2n plus 1, limit n tending to infinity, summation n equal to minus n to capital N and xn whole square. You can also write it as a limit capital N tending to infinity 1 by 2n plus 1. Now from minus n to minus 1 its value will be 0. Only from n equal to 0 to capital N its value is going to be n. Okay, so it will be n square. So now we need to apply some formula here. So summation of n square from n equal to 0 to capital N. So you can write it like this, limit n tending to infinity 1 by 2n plus 1. Now when you, if you know from the mathematics, when you solve this, you'll get this kind of term, n into n plus 1 to n plus 1, all these are capital N, by 6. Okay, this is what you will get. This 2n plus 1 and 2n plus 1 cancel out each other, and when you put infinity, you'll get infinity here. Okay, and because of that, the power of this signal will be infinity. Anyone has any doubt in this? Okay, let me go to the next slide. Now these are some few basic operation that people generally get confused with. So I've just illustrated it here. Time shifting operation. So what does it mean by time shifting? So let's say you have a signal x of t which looks like this. Okay, and when you do the time shifting, let's say you want to shift it by 1. So you denote it by xt minus 1. So when you do this operation of time shifting, what it means that you're taking this graph and shifting right by 1. Okay, when you do xt plus 1, it is shifting it left by 1. So whenever you see there is a minus sign, it means that we are shifting it on the right side, and whenever you see there is a plus sign here, it means that we are taking the signal and shifting it on the left side. So this is how we do the shifting operation. The time scaling operation. So let's say again I have taken the same signal here and I'm doing the time scaling. So what does it mean by time scaling? It is generally represented by yt equal to x of at. Okay, where a is the scaling factor. So let's say a is equal to 0.5 for first example. Okay, so when a is equal to 0.5, the signal which is here, it now looks like this. Okay, actually this will be 4 here. So whenever you do this time scaling, and the signal will get compressed or expand based on the value of a. So you see in this case, the signal is getting expanded. In this case, signal is getting compressed. So in this case, value of a is equal to 2. In this case, value of a is equal to 0.5. Okay. So whenever a is less than 1, signal is getting expanded. Whenever value of a is greater than 1, signal is getting compressed by. Okay, so the compression amount depends on the value of a. Here here the value of a is 2, it means that it is getting compressed by factor of 2. Here the value of a is 0.5, which means that it is getting expanded by factor of 2, which is opposite of 0.5. So in the case when a is less than 1, the expansion factor will be this, which is so it is like 1 by a. So by this much factor, it is getting expanded. In the second case, it is getting compressed by this much factor. So based on the value of the a, it will either get compressed or it will either get expanded. Now let's talk about the same thing about the digital signal, or sorry, discrete time signal. So you have, let's say, signal y of n. and which is equal to x of n minus 2, and this is x of n. So again, it means that you are shifting it right by 2. So this is how does it look like. You take the signal, shift it right by 2. Okay. In the case of discrete time signal, the time is scaling is very different than the continuous time signal. So for example, let's say I want to calculate x of 2on. Okay. So we know that when the factor a is more than 1, we are kind of compressing the signal. But in the case of discrete time, when you compress the signal, some of the values goes away. That means we are losing the sum of the signal. So for example, when you do this compression here, this x of 2n, 0 for n equal to 0 value is appearing directly, but for n equal to 1 value is getting missed. This value got discarded. Okay. This value got discarded. N equal to 2 is coming here. This value got discarded, and n equal to 4 is coming here. Okay. So what you see here is that whenever n is some odd number, okay, for x of n, whenever there is an odd number of n, those values are getting discarded. Okay. Why it is happening? So let's say this y of n is equal to x of 2n. Okay. Now let's say this is y of n, right? Y of n is equal to x of 2f. Now let's say I want to calculate y of 0. So when you put n equal to 0 on the right side also, you will put 0, it will become x of 0. And what is x of 0? This 3, which I have put it here. When you calculate y of 1, y of 1 will be equal to x of 2, okay, which is here, and that I will put it here, right? Y of 1 is equal to x of 2. Okay, this is y of 1 is equal to x of 2. So you see here, this value got discarded because of this scaling operation. Okay. So this operation we also call as a decimation operation, where we decimate the sum of the value of the x of n. Okay. Anyone has any doubt till this point? Okay. Now second is this thing x of n by 2, where we are doing just the opposite operation of this x of 2n. Okay. In this case, let's say this h of n, I want to calculate h of 0. It will be equal to x of 0. Simple. You just take the value here, which is 3, put it here. Now let's say I want to calculate h of 1. If you calculate h of 1, it will be x of 1 by 2. And we know that x of 1 by 2 doesn't exist, right? Because x of n is there only for the integer value of n. That was the definition of the discrete time signal. So it means that x of 1 by 2 doesn't exist. Okay. So let's hold for here. Now let's calculate the x of 2, h of 2, which will be equal to x of 2 by 2, which will be equal to x of 1. Okay. This x of 1 we have here, which is 4. Let's put it here. So this is equal to h of 1. Okay, sorry, h of 2, which is 4 here. Now in between we are missing for n equal to 1, because n equal to 1 we got the x of 1 by 2, which doesn't exist. So what we do here is that based on the value at n equal to 0 and n equal to 2, we do kind of averaging and put the average value at n equal to 1, which will be in this case is 3.5. Okay. So this operation of getting the value at n equal to 1, which was not there, which was not available in the x of n, we call it as an interpolation. Okay. So when you do this operation, we call it as a decimation. When we do this operation, we call it as an interpolation. Okay. In the case of decimation, you are going to lose the some part of the signal. In the case of interpolation, you don't have some of the information, you get those information to the its adjacent value. For example, n equal to 0 and n equal to 2 for n equal to 1. Anyone has any doubt? Now this time reversal we have not covered yet. So what is the time reversal? So let's say you have a signal x of t which looks like this. You want to calculate a new signal y of t which is x of minus t. What you do is you take the signal x of t and just flip it around this y-axis, and that will give you the time reversal. This one we have seen just a few slides back in one of the example. So whenever you have to calculate the time reversal, just take the signal and flip it with respect to this vertical axis. So this is how we calculate the time reversal. Let me go to the next. Now this is one of the gate problem that I've taken, gate 2005 EC. We have been given a sequence and its non-zero value is shown in the figure. We have a new sequence y of n which looks like this: x n by 2 minus 1 for n equal to even and 0 for n equal to odd. We need to just simply plot what is this y of n here. We need to find out of this 4 option, how does the yn look like. Okay. So for the odd value of for n equal to odd, we know that yn will be equal to 0. It is given in the problem itself. Okay. So now if you see these options, this B option and D option has value at n equal to odd, right? So you can simply eliminate them. Now we need to find out our answer based this option A and option C. Which one of this is correct? Now for that we need to go above here, xn by 2 minus 1 for n equal to un. Now let me find out what is the y0. Okay, so y0 will be equal to x of 0 by 2 minus 1, which will be x of minus 1. Okay. What is x of minus 1? This value, which is 1 here. Okay. Now if you see the this option A, its value is 1 here. This value is also 1 here. Okay. Now let's calculate next value, which is y of 2. Okay. So y of 2 will be given as x of 2 by 2 minus 1, which is equal to x of 0. And x of 0 is equal to 2, right? This 2 value. X of 0 is equal to 2. Now if you see the option A, for n equal to 2, the value is 2 here. But if you see the option C, for n equal to 2, value is half. So it means that this is not the correct answer. This is the correct answer. Okay. Anyone has any doubt in this problem? Now let me go through quickly some of the elementary signal. So one is the complex exponential signal, which is generally represented by cos omega naught t plus j sin omega naught t. And since we know that this cos omega naught t is a periodic signal and sin omega naught t is a periodic signal, and both of these two has the same time period and same frequency omega naught. So it means that e to power j omega naught t will also be a periodic signal. Okay. And for the discrete exponential, again from the Euler's formula, you can write it like this: cos omega naught n plus j sin omega naught n. And just like the cos omega naught n and the sin omega naught n, this complex exponential may or may not be a periodic signal. And again, to find out whether this complex exponential in discrete time is a periodic or not, you need to find out this, whether this omega naught by 2 pi is a rational number or not. We go to the next slide. Now we are covering the some of the elementary signals. So one was the, in the last slide was the complex exponential. Now this is the unit step. This one we have gone through one of the problem. I will just quickly go through it. What is the unit step? So unit step is defined like this. So from minus infinity to 0, its value is 0, and from 0 to infinity, its value is 1. This is the continuous time. In the discrete time, again, minus infinity to minus 1, its value is 0, and from 0 to infinity, its value is 1. Okay? This is what we call it as a unit step. This is called the unit step because there is a step at n equal to 0, and the step value is 1. That's why we call it as a unit step. Okay? Next is the unit impulse signal. This is very important signal. This is we are going to use throughout the signal and system, because this, with the help of this only, we will be able to find out the something called impulse response. That we'll see later what is the impulse response. So the unit impulse is defined as something like that. This, so it is defined only at t equal to 0, which value is infinity, and for rest of the value of the t, its value is 0. So it value exists only at t equal to 0, where the value is infinity, and for rest of the value of the t, its value is 0. Now there is a special property of this delta t, and that is that if you integrate this delta t, which is the impulse signal, from minus infinity to infinity, or let's say some value, let's say minus a to a, its value will always be equal to 1. Now we call it as a unit impulse signal because its area under the curve is 1, because this integration is 1 and integration is same as the area under the curve, and it means that the area under this impulse is equal to 1. Okay, that's why this unit term is coming. Okay, unit impulse function. If it is just an impulse function, then area under the curve can be any number, though its shape will be same as this. It will value will be equal to infinity at equal to 0 and 0 for rest of the time. Now there is a relationship between the unit step and the unit impulse, and that is this, that when you differentiate the unit step, you will get the unit impulse, and when you integrate the unit impulse, you will get the unit step. Now if you know the unit step looks like this. From n equal to 0 to minus infinity to 0, its value is 0. Now from 0 to infinity, its value is 1. Okay? Now whenever you are going to differentiate any signal, it means that you are going to calculate the slope of that signal. Okay? So if you see this unit step at t equal to 0, what is the slope of this signal? So it is abruptly changing from 0 to 1 in no time. There is no time, and it is changing from 0 to 1. So that means that the slope of the signal at t equal to 0 is infinity, and that's what is the delta t. Okay? Delta t is the derivative of the ut. So derivative of the ut will be equal to 0 from minus infinity till 0, but at t equal to 0 there is a slope which is equal to infinity, and then again from 1 to infinity the slope is 0. Okay, so that's why this is the relationship between the unit step and the unit impulse function. Okay, unit step is the integration of the unit impulse, and the unit impulse is the derivative of the unit step. Anyone has any doubt? There are some very important property of this impulse function. I will go through it now. Okay. So if you shift this unit impulse, let's say by factor of a, the impulse will now be located at t equal to a. and it will be given by this t delta t minus a is equal to infinity at t equal to a, and for rest of the time its value will be equal to 0. Okay. Now if you multiply this delta t with any signal x of t, you will get x of 0 multiplied by delta t. Okay. Similarly, if you have any signal x of t, when you multiply it with delta t minus a, you will get x of a delta t minus a. Okay. So this two property is widely used throughout the signal and system. So one property is that they are kind of same property. Once you put a equal to 0, you'll go back to here. So delta t minus a into xt will be equal to x of a delta t minus a. Now, what will be the this integration? So you have delta t minus a into x of t. Okay. We know that delta t minus a into x of t, you can also write it as a x of a into delta t minus a. Okay. So this you can write it as a x of a minus infinity to infinity delta t minus a. Okay. I have taken this x of a out because it is a constant. It is not a function of time. Now we know that when you integrate the delta t from minus infinity to infinity, its value is equal to 1. So this value will be equal to 1. Finally, you will get just x of a. Okay. Now, here people make a mistake by writing that x of a is same as x of a into delta t minus a. This is not true. These two things are not same. Okay. I have seen a lot of students making this mistake. They equate these two things. Okay. This is never true. X of a is not equal to x of a into t minus. Okay. When you plot the x of a, let's say there is a signal g of t, which is equal to x of a. What does it mean is that x of a is a constant, which means for all the value of t, when you plot this gt, you will always get a constant, which is x of a. This is how it is going to look like, this gt. But when you plot this x of a into delta t minus a, okay, it is essentially an impulse located at t equal to a. And it is not a unit impulse because here you see there is a x of a. If it were just a delta t minus a, you can say that it is a unit impulse, but it is getting modified by this x of a. So you can say that this is an impulse with a strength of x of a. Okay. For the unit impulse, we call it as a strength is equal to 1 because area under the curve is x1. In this case, the strength is x of a because the area under the curve is x of a. Okay. Because when you are integrating it, you are getting x of a. Anyone has any doubt in this? Okay. Let me go to the next slide then. So this is all about the continuous time continuous time impulse function or impulse signal. But when we come through discrete time, it is very simple. There is no all those definition that we saw. It is pretty simple here. The delta n will be given as just equal to 1 for n equal to 0, and for rest of the time, its value is 0. Here, there is no definition of area under the curve because it is a discrete time signal. Okay? And there is one property which is very similar to what we saw in the last slide for the continuous time is that if you have x of n, multiply with delta of n, it will be x of 0 delta of n. When you have x of n multiplied with delta of n minus a, it will be x of n delta n minus a. Okay? Now again, same what we saw in the last slide, that delta n is the derivative of the unit step. Now since for the discrete time you cannot calculate the derivative, this derivative becomes a difference equation. okay, difference equation, and because of that the delta of n will be equal to u of n, u n minus 1. Okay, so what does it mean is that we know that un looks like this. This is a unit step. What is a un minus 1? So when you plot un minus 1, it will start from 1 and go till infinity. Okay, n equal to 1, 2, 3. It will start from 0, 0, 1, 2, 3. So this is u of n. This is u of n minus 1. When you subtract this 2, so from minus infinity till minus 1, both of them were 0, so subtraction will also be 0. But at n equal to 0, the value of un is 1, but un minus 1 is 0. So it means the subtraction will be equal to 1. So you'll get 1 here. Again, from n equal to 1, both of them are 1. N equal to 2, both of them are 1. So it means that they will, when you subtract this 2, they will become 0. So here 0, 0, 0, 0, and so on. So you see this signal is same as this delta n. So this differential equation becomes a difference equation in the case of discrete time impulse and unit step relationship. Similarly, if you write ut equal to integration from minus infinity to t delta t dt for the continuous time, for the discrete time, this integration will become summation. Okay, un is equal to minus infinity to n delta k. Anyone else has any doubt here? Next is the unit ramp. So this one briefly we covered what is the unit ramp. So as the name suggests, this is a ramping up with the time. So for n equal to minus infinity till 0, there is no ramp, it is always 0. But from n equal to 0 to infinity, it is going up with a slope of 1. Okay, so it means that it is a kind of a straight line passing through the origin with slope equal to 1, which you can simply write it as a t. Okay, rt equal to t. Okay, so rt is equal to t, which is a equation of a straight line passing through the origin with slope equal to 1. For t greater than equal to 0 and for t less than 0, it will be 0. Also, this rt can be written as t into ut. Okay, so if you write just t without ut, it will be all the way from minus infinity to infinity. This is how the t looks like. But you once you multiply ut, okay, this is the ut. When you multiply this signal with this signal, which is t into ut, you'll get this ramp. Okay, why? Because from minus infinity till 0, the value of ut is 0. So it doesn't matter what is the value here. When you multiply this 2, you'll get 0 from minus infinity to 0. Now from 0 to infinity, this value is 1. Since this is 1, whatever the value is there for the rt, sorry, it is t here, the same thing will appear here, because here it is 1. Now there is one more relationship between the rt and the ut, that is when you integrate the ut, you get the rt. When you differentiate the ut, when you differentiate the rt, you get the ut. So ut is d by dt of rt. This is about the continuous time. Let's go to discrete time. So discrete time we have just briefly covered in one of the problem. This is how the ramp looks like, unit ramp. So in this case, when n is equal to 1, value is 1. When n is equal to 2, value is 2. When n is equal to 3, value is 3, and so on. This is how it goes up. For every value of n, the signal also goes up by n. So if you move right by, let's say 2, signal will also go up by 2. Again, here this relationship is integration. In the case of discrete time, this will become a difference equation. And sorry, there's not a correlation. this one. This is the differential equation. This will become a difference equation, and this is the integration. This will become a summation in the discrete time. Okay. So again, it is very similar to what we see in the continuous time. Only the thing is that it is instead of differential equation, you have a difference equation. Instead of integration, you have the summation. Anyone has any doubt till this point? Okay, this one we have briefly covered. So that's all I have for today's class. So in today's class, we covered all the basic of the signal. So basic of signal. Okay. And then we covered, so in the basic of signal, what we have covered, classification. Okay. And then we saw what are all the elementary signal. Okay. Elementary signal include this unit ramp, unit step, unit impulse, sinusoidal, and complex exponential. In the next class, we will start the basic of system. I will share this. Yeah, I will share this PDF with Dinesh. He will share this PDF with you guys.